The iterator pattern provides a way of iterating over an object without having to expose the object's internal structure, which may change at some point in the future. So changing the internals of an object should not affect its consumers. So this probably doesn't make too much sense to you, so let me show you what this means with an example. So here we have a shopping list class which stores a list of items, and we have a push method to add an item onto the list, a pop method to remove the last item on the list and then return it, and we have a get list method which returns the whole shopping list. And as you can see here, the shopping list is of type list. It is a list data structure, and each item in the list is of type string. So let's actually use this shopping list in our program.cs file. So I'm just pasting in here where to create a new shopping list called list, and then we're just pushing a few items onto the list, so milk, bread and steak. And now what we want to do is we want to loop over each item in the shopping list and log each of the items. So we can create a for loop starting from 0, and the loop will keep running until as long as I is less than the list length, and we can call count on here. So let's see, list.getList.count, and we want to increment I by 1. So this is giving us an error, cannot convert type int to bool. So this should be as long as I is less than the length of the shopping list. Okay, so this is going to loop over each item in the shopping list and increment I by 1 each time. So let's have a look at each item in the list, and we can do that by saying list.getList, and we can access the nth, or the ith in this case, item in the list. And then we're just going to log this item. Okay, so let's run this program and see what we get returned. And you can see we have milk, bread and steak as expected. So this looks like a decent solution. However, there is one problem. And the clue, if I give you a clue what the problem could be, it's this sentence here. So changing the internals of an object should not affect its consumers. So if we change the internals of the shopping list object, meaning we change something within this shopping list class, then it should have no effect on its consumers. And currently this program.cs main method is a consumer of shopping list. Okay, so let me show you what the issue actually is. So if we changed the data structure inside of shopping list to a fixed length array, so if we just comment this out for now, and then we say private string, so a string array, list equals new string array, and it's a fixed length array of 50 items long. So if we change the data structure used to store shopping list items, and then let's just say that we updated all of these methods to push, pop and return the list. Okay, we're not going to do that for now because we don't really need to. But if we go into our program.cs, then it would actually cause an error because fixed length arrays do not have a count field. And currently, list.getList inside of our shopping list would return a fixed length array. Okay, it wouldn't return a list, and a fixed length array does not have a count field, so therefore it would cause an error. It would cause our program to break in this consumer. It affects this consumer. So by changing the internals of the shopping list object, it would affect its consumers. Any consumer that is iterating over the list will break. So we can fix this by using the iterator pattern. So we can use the iterator pattern to ensure that changing the internals, for example changing the list data structure, doesn't affect any of its consumers. So we can do this by adding some methods to the shopping list class to allow iterating over a shopping list without knowing about its internal representation. So here we have a UML diagram of the shopping list class, and we can see that we still have our push and pop methods, but we've added some extra methods to allow iterating over a shopping list. And you can see here we have a next method, a current method, and a has next method. So what we've done here is we've added these three new methods to help consumers to iterate over the list data structure or just the object itself without having to have any knowledge of the internal data structures. So the next method goes to the next item in the list, the current method returns the current item, and the has next method checks if there is another item in the list. And with this structure we don't know the internal representation of the list object. So if we change the data structure used in shopping list to store items, its consumers wouldn't break or need to be changed. We just have to perhaps update the iterator methods to account for the new data structure. So the problem with the above shopping list class is that it violates the solid single responsibility principle, because shopping list is now responsible for list management using push and pop, and it's also responsible for iteration using next, current, and has next. So to follow the single responsibility principle, we can put the iterator methods into a new class, and that class can be called iterator. Okay, and as you can see, the shopping list has a dependency on iterator. And as you can see here, we also have a method inside of our shopping list class called createIterator, and the createIterator method returns an instance of iterator that allows consumers to iterate over shopping lists without knowing its internal details. However, we have another problem, because if the data structure inside of shopping list changes, then we will need a different iterator to manage it. So iterator needs to be an interface, and then we can have concrete classes for each data structure that implements iterator to ensure that they contain the iterator methods, the correct iterator methods, and the interface determines the capabilities that we need from a real concrete iterator. So the data structures could be an array, a list, a stack, etc. So here is our UML representation. We have our shopping list, which has a createIterator method, which returns an iterator. And we have an iterator interface here, and iterators should have a next, current, and has next method. And then we have our concrete representations of iterators, and each concrete iterator can be used to iterate over specific data structures. In this case, we have a list iterator for iterating over lists, and an array iterator for iterating over arrays. So we can see here that shopping list has a dependency to the iterator interface, as we discussed, because the createIterator method returns an object of type iterator, and the concrete iterator classes extend iterator and implement its methods. So here's how the solution looks using the gang of 4 abstract class names. So we have a collection class which contains the createIterator method, and obviously this is our shopping list class in our example. We have the iterator interface, okay, and createIterator returns an object of type iterator. And then we have our concrete iterators. Okay, so now let's implement this in code. So let's now implement the shopping list using the iterator pattern. So I've created a good example folder here, and I've copy and pasted the shopping list from earlier into this new folder. And we're going to refactor this to satisfy the iterator pattern. So first of all, what we need to do is create an interface for the iterators. So I'm going to call this Iterator, and this needs 3 methods. So we need a method called next, we need a hasNext method which has a return type of Boolean, and we also need a current method which returns the current item in the loop. So currently this current method only works with strings, and that's fine for our shopping list because we have a list of strings. However, what if we wanted to loop over a list of orders or customers or integers? So this iterator interface isn't very flexible. It can only work with lists of strings. So what we can actually do to make this more flexible is use a generic type and pass this to the current method. And if this doesn't make sense to you, it will make more sense when we use this Iterator interface shortly. So what we now need to do is create our concrete iterator classes. So we're actually going to create these as nested classes inside of this shopping list class. So let's create a nested iterator, and I'll explain why this is nested soon. So we're going to create a private class called list iterator, and this is a concrete class which is going to iterate over lists. So currently that's what we are that's the data structure that we are using for our list, and this needs to implement the Iterator interface, and we can just pass a string data type to that. Now, as you can see, we get an error because we haven't implemented this interface. So let's do that, and let's now create some fields in this concrete iterator object. So we're going to have a shopping list field, because that's what we are looping over, and we will also have an index, so the current position in the loop. And then we also need a constructor which takes a shopping list and we assign it to the shopping list field. Okay, so now let's update our current method. So this should return the current item in the list. So we can return the shopping list dot list, and then we can just pass the index like so, and this will return the item at the current index in the loop. And then next, let's implement this next method. So all next needs to do is increment the index by 1. So we can just say index equals index plus 1. And then the hasNext method needs to check if we are basically at the end of the list. So we can return index is less than shopping list.list.count. And here we do have access to the count field because we know that we are iterating over a list, because this is a list iterator. Okay, so we just need to put colon there. Okay, so this is all looking okay. And then in the in our shopping list class, we just need to do one more thing, and that is to create a new method called createIterator, which is going to return the correct iterator. Okay, so in this case we need a list iterator because we are using a data type of list. So let's create this method, and this has a return type of iterator, which allows us to use multiple different types of concrete iterators. So we can return any concrete iterator and it isn't going to cause our clients to break. So here we're going to pass a string because we are iterating over strings, and we can call this createIterator. And this needs to return new list iterator. And we pass the current shopping list. Okay, so that is all looking good. So let's actually test this solution out. So we are no longer going to need this, so let's remove that. And let's create our new iterator. So we can say iterator. In fact, let's just do this. We can say var iterator equals hold on a second. So okay, so we can say var iterator equals list dot create iterator. So now we have our iterator, and now what we can do is we can create a while loop. So we can say while the iterator has next, we can console write iterator.current, so get the current item in the iteration cycle, and then we just call the iterator.next method to go to the next item in the list. So let's log this out, and as you can see we still get milk, bread and steak as we would expect. And the advantage of this is now we can safely change the data structure in shopping list, and the code in all of our consumers will still run. Because if you look at our shopping list, currently we have a list of strings, but if we change this to a fixed length array, we could create a new class called fixed length array iterator, which implements the iterator interface, and it provides these methods. And then in our program.cs file, this would still work because we're just interacting with the methods that are specified on this interface. So because we are effectively coding to an interface, we now don't have to worry about the specific internals of the object that we are iterating over. So when should you use the iterator pattern? So it's a good idea to employ the iterator pattern when your collection possesses a complex internal data structure, or a data structure that is likely to change, so that clients can iterate over the collection without any knowledge of the data structure. So if the internal data structure of an object or of a class changes, then it shouldn't affect the clients. So what are the pros and cons of the iterator pattern? So one of the pros is that it satisfies the single responsibility principle, because the traversal logic is abstracted into a separate class or separate classes. And it also satisfies the open-close principle, because you can create new collections and iterators without breaking the code that uses them. And one of the cons of the iterator pattern is that it can be over-engineering if your app only works with simple collections.